Alex, thanks for joining me on our inaugural SurePrep Zoomcast series. You want to maybe just introduce yourself for the viewers?
Yeah, sure. My name's Alex Sadovsky, and I am the VP of AI here at SurePrep.
All right. We were talking earlier, and I mentioned, I think, artificial intelligence and machine learning is still seems like sort of science fiction for a lot of people. So there are probably some, misconceptions. So I guess my first question for you, what are the common misconceptions about artificial intelligence and machine learning? In other words, what is it and what is it not?
Yeah, no, that's a really good question. I think, artificial intelligence actually goes back a long time. It's not necessarily a completely recent discovery. And really, artificial intelligence, put quite simply, is just teaching computers to act like humans. And so 30, 40 years ago, the way that we used to do this was we would just think of everything a human would do, and we would make a giant list and say, if you see this, do this. If you see this, do this. And this was called expert systems. Basically, you'd get a bunch of experts in the room and you'd say, all right, write every situation that you want a computer to respond to, and we're going to have computers do this. And that was AI, and that was like kind of the early aspects and startings of AI. And where we've gone from there now is, how do we get away from needing a group of experts necessarily to train a system and using lots of data so that a computer can learn on its own? And so really modern AI is really focused around how do we take data and teach computers to act more like humans. AI can be anything as simple as trying to create a system to recommend if something is a cat or a dog, or it could be a self-driving car. It's really a wide spectrum there. One of the misconceptions, though, around AI is a lot of organizations, companies across the business spectrum go in and they'll say, we need AI for our data. AI is the future for us. And really, what those companies need isn't machines that act like humans. They just need more sophisticated data and more sophisticated software engineering. An Excel spreadsheet or a SQL query might be all they're really looking for when they're saying they need AI. They just need data processing. And so I think there's a lot of misconceptions that begin around there. The way that I like to kind of use as my litmus test of, is AI necessary for an organization, or can AI solve your problems, often is there patterns that you could have a computer find? Is there some sort of behavior that a human is doing that you want a computer to be able to replace, either to increase your operational efficiency or to do something more accurately? This is really kind of my litmus test at a high level for, is AI necessary and can AI be used to solve a problem?
Got it. Good clarification. So, Alex, when you create an AI or ML model, how do you know that what the computer is doing, it's doing correctly?
Yeah, and so this is actually a really hot topic in modern AI. A lot of initial systems with neural networks and deep learning were what we'd like to call black box, where basically data would go in, an answer would pop out, and you wouldn't really know how it's working. And with systems like this, there's still ways to kind of make sure AI is working correctly. But I bring this up because one of the really cool things that we're doing nowadays in AI, and one of the kind of biggest foundations, is model explainability. And so being able to have your model have an expert go in and be able to kind of delve into your model and have it explain what it's doing. And so AI is extremely complex. The way that computers think is, millions of operations per second. And so we're not able to understand exactly every little aspect of what's going on inside an algorithm. But what we can do is dive into the algorithm and start to see patterns that we know and understand. So for example, I'll go to the classic example of a dog versus cat. If the model is saying, oh, it's using the shape of the ears, or it's using the length of a tail, or the fur, or maybe the size of the animal, if you can pull out little features like that, and they kind of correlate to what the model's doing, it helps you give an idea of, okay, the model seems to be doing something right. And so that's very much on kind of the algorithmic side of how do we dive into these algorithms. But at a much simpler case, we can really back up and say, how do we know that AI is doing something intelligent? And the way that we can do that is we can test it on known cases of data that we have already. And so a great example of this is we make a system that's supposed to predict is someone more likely to want to buy a red shirt versus a blue shirt, say, in some sort of AI type sales system. And what we would do is actually run this system alongside someone's consumer behavior. And we would just watch what's happening in the wild. And so we're kind of having our system set out there, we're observing it, and we're making sure that it's making the right decisions. And at the end of the day, we can go back and say, yep, it looks like this model is doing the right things, or here's the cases where it's failing. Here's the issues that we're having. And the last test here, AI really is powered by humans. And so, and what I mean by that is it's powered by data that's being fed in, it's powered by our own biases and assumptions about what a model should or shouldn't be doing. And so we ultimately can back test back on people as well. And so for any type of industry, if you have experts in the field, it's really great to get those experts to go in and then those experts to look at what the model's doing. Everything from, is the model giving high confidence in certain areas or not? Is the model extremely biased? And have those experts say, does this make sense given what we know about the problem? And those experts are really that last aspect that can fine tune a model. And we can actually retrain the model based upon those experts' opinions as well at the end of the day.
So just to summarize, you can basically look at what the machine is doing and compare it to what the human counterparts either you expect them to do or they actually did, and that's one of the ways you can gauge the accuracy.
Yeah, exactly. Everything kind of goes back to, at the end of the day, we are still people are still the ultimate arbiters of, is this right or wrong? And so using AI to create lots and lots of predictions or lots and lots of assumptions, or kind of to create that analog of human intelligence, but then having humans judge, is this really being done intelligent, or did the computer make some error along the way that we might want to fix in the next round of testing?
Got it. Understood. You mentioned using lots of data to train models. Obviously, data privacy is a paramount concern. How does data privacy come into play in terms of using it to train models?
Yeah, and so every organization I've worked with, if you're training AI, you're working with often live data or some type of data, and really you have to be the guardian of that data. And so when I think around data, one of the most important things that comes to my mind is PII, or personal identifiable information. These are things like names, addresses, social security numbers, bank statements, and any number that would be, you wouldn't want getting out into the wild. And so one of the really great things about AI is that traditionally AI and machine learning in general is that machines don't really care about the individual as much as you or I would. Machines are really interested in the patterns. And this could be anything from, if you're trying to make a filter that distinguishes a dog versus cat, it doesn't care about the individual dogs, it cares about, what do dogs look like as a whole? What do cats look like as a whole? And relating that now to, let's say, the financial world, you're trying to make a model to understand if someone's capital gains are scanned correctly or incorrectly from a document. You don't really care about that individual's capital gains. You kind of care about the relationship of the different numbers that they might have on a document and how those would refer to a distribution of numbers of capital gains that you might see across a whole population of thousands of people. And so what's great about this is that those PII numbers that we talked about, your social security numbers, your names, et cetera, a lot of those don't even need to be taken into account while doing any type of machine learning. Essentially what you need is a unique identifier. And so one of the initial things that we do in a lot of our research is we pull out names, we'll pull out social security numbers, and we'll do what's called obfuscating them. So a lot of the names, we have a lot of our tax returns actually correspond to Jack and Jill. They're a married couple, and so we switch out those names, and now we have a joint return between them. Social security numbers will keep the same format, but it might be like 111-22-3333 or something like that, just because those numbers don't really matter as much to us. So we can guard data in that way. And then the second way that we're looking at data is we're taking data in. So we might take in raw numbers on a tax document, but those numbers aren't being stored by the model. At the end of the day, the model is going to create an equation from those. It's going to think about statistical distributions. The raw individual information per user isn't being taken into account by the model. It's understanding what are relationships and things that we see in aggregate around a population. And so what's really great about this is at the end of the day, you get your model, which really is this set of equations. And those set of equations explain potentially a single field on a tax document or a way that language appears on certain tax documents, et cetera. But they are devoid of individual information. It's all aggregate information. And so we take all of that kind of personal information and individual information, it comes together and it creates this model that is more than the sum of its parts. And the best part about it too is that it can't really be broken apart into those individuals' information. And so the information of an individual is kept safe along the whole process.
So the data is anonymized. The machine doesn't care what the dog's or the cat's name or address is. So Alex, what are some of the biggest challenges in implementing artificial intelligence and machine learning as a part of the SurePrep process, and how are we tackling those challenges?
Yeah, so I think one of the biggest challenges that I've found is, especially in the tax preparation space, while it's a standardized space, there's actually a lot of differences as well. There's a lot of non-conformity in how taxes are done. And so this refers to the idea of property taxes and every single county having their own unique way to do them. So you have over 3,000 different ways someone can do a property tax. There's humans will write all over tax forms. They'll cross things out. They'll highlight them in different colors. They'll write little notes to their accountant. There's all these different aspects that come in across the board. And so when I first kind of came into this space, I thought of your traditional, your 1099 int forms and all these IRS forms. And really that is actually a small portion of what you see in the tax world. There's a lot of very custom documents. And so, that was one of the big challenges initially, is how do we kind of react to this kind of breadth of documents that are almost too much even for a human to look at. And so one of the ways that we've been approaching that is using different AI that both looks at the visual aspects of a document to understand what type of document it is, where different information is stored in that document, where there's handwriting, where there is something that is part of a common form. And we've created ML filters that go through and identify those elements. But then another area is creating ML that can do natural language processing on documents. So looking at different words on a page to be able to say, oh, this is a DMV statement, to understand that total amount due might be the same as vehicle tax or something like that. So being able to understand basically the language of the tax world. One of the areas that comes into play, which is really cool, is in things like charitable contributions, where often you'll get a letter from a charity saying you made a contribution. By being able to use natural language processing, we can parse through that letter and understand what part of that letter is relevant to your tax case and which part of that is just kind of generic speak around a contribution that is being made. So that's one of the big issues that we've come into. The other area with AI/ML that I think is unique to the SurePrep process and just public accounting as a whole is that most industries don't have one day a year where all projects are due. And what I mean by that is in tax season, we might be processing millions of documents a day, while on December 20th, maybe 2 documents hit our system and it's probably someone testing it in the first place. And so not only do we have to build AI ML systems that are capable of being accurate, they have to be able to scale to really this deluge of information that comes during the tax season. And so writing scalable AI that's extremely efficient while still maintaining that accuracy has been a really big focus for us. And we've been doing that using a lot of new advances in cloud computing that make this a lot easier for us at this time.
Nice. So given those challenges, and I'm sure there are many, many other challenges you just didn't have time to mention, can you imagine a future of 100% automation through artificial intelligence and machine learning, or is that 100%, unattainable?
Yeah, and so when I think of a 100-year roadmap for my team, I'd love to say let's get to 100% automation. Tax processes, at the end of the year, you give your data to SurePrep, you kind of scan your documents, and instantly your tax return is completely finished. However, humans are likely always going to be needed in the loop, especially for the short term. And so a lot of what we see is that there's a lot of new use cases. There'll be completely new use cases in the tax code. There'll be completely new documents. We never know what's kind of going to come down in the future in terms of different changes to laws or way documents are described, et cetera. And so having humans in the loop to inform AI or to help us kind of retrain our models to understand what might be new is always going to be a big part of it. And the way I think about it right now is that it's a pretty lofty goal to be 100% automated in anything. You think of even automated driving, and they still, at some point want you to put your hands on the wheel because we're still not all the way there. And humans are just really complex thinking machines that rival most computers in a lot of ways. The one area, though, where I would say computers are better than humans are doing routine and manual kind of transactional type of work. And the good thing is this is the work that most accountants, most humans hate doing in the first place. And so really where I see AI ML kind of creating hopefully a 100% success rate is AI and ML can replace all of that routine, kind of monotonous, repetitive work. And that's really what I think the goal is over the next 10 years or so in the AI ML space. And then beyond that, more and more automation. I think humans will still always be in the loop a little bit, but probably less and less so as we continue on. But right now, we really need those experts kind of watching these systems. And the great part about what we're doing is that if we get rid of that routine work and very manual work, those humans can spend their time doing intelligent, creative things as opposed to kind of clicking boxes or retyping one form to another.
Got it. Yeah. No one got into tax and accounting to do, data entry, which is the kind of thing that we're trying to automate. I'm going to make a note for myself to check back with you in 100 years and see how far along the roadmap we got.
Yeah. The good thing about making a 100-year promise is I probably won't be around to cash in on that bet. Or
yeah, true. Next question. So you used to work in advertising technology and neuroscience. Can you explain a little bit about how that relates to work in the public accounting industry?
Yeah, definitely. Whenever people talk to me about kind of my background, it seems like I've done very different things, everything from biology to kind of advertising technology to now public accounting. But really, there's been three underlying areas that have stayed the same throughout this whole process, and it's really this combination of taking data, applying math to it, and then using computers to kind of do that at scale. And so, along the way, everything has. When I studied the brain, it was really the brain has trillions of synapses of connections in it. And you really need a lot of high powered computing to do that. When you think of online advertising, there's billions of cookies on the web and you need advanced computing to process that as well. And so really kind of the ingredients in all of these spaces has stayed the same. And just to make some specific kind of comparisons here, in ad tech, we would have this question where it would say, given someone's website history via a cookie, what would be the best ad to show them? Is this the kind of person who wants to buy high-end men's clothing, or is this the kind of person who would rather just kind of buy beach sandals or something like that? And so there is that question there. In accounting, we might have a question though, given these numbers on a form, or given this data on the form, we want to reclass a field. So it's a K1 and we know that someone is writing something, we want to reclass it. What should we reclass that to? And so in both cases here, we're taking a lot of data. It's either your web history or the data that's written on a K1 form. And we're trying to make a decision based upon that, essentially put someone into a category. Either say this is the kind of consumer they are, or this is the kind of data entry that appears on this K1 for reclassification. And so they seem like very different questions, maybe at the onset, and they're in two very different verticals. But the methodology underneath it stays the same. And a lot of the techniques in ML, kind of math and science that's been developed for these problems has stayed exactly the same between these two realms. Another kind of fun one, example kind of in the same realm is in neuroscience. A lot of the ways that you can look at the brain is there's a lot of different cells and they're all connected to each other, and it's kind of this jumble of wires. And so what you often use in neuroscience is the idea of graph theory, where if you think of the brain as kind of a graph where certain processing's happening here and memory's happening over here and maybe senses, you're smelling something over here, and how those things connect, there's a lot of math around that. And so what we've actually been doing lately at SurePrep is some really cool work around understanding how different documents relate to one another. And so when you're thinking of a binder or a tax return for a year, you can actually think of it similar to a graph of, if you have this document, you might also have this document. And if you had these documents last year, they would also create a similar pattern, and you can look for commonalities between the graphs. And there's a whole branch of mathematics called graph theory, which turns graphs into really simple, or not simple, it turns graphs into really just a complex, interesting way of looking at data and making more kind of conclusions from that data. And so again, it's something that I hadn't worked on since my days in neuroscience, probably over 10 years ago, and it's starting to creep up again in my daily work here at SurePrep, which is really, really interesting.
Yeah, that is interesting. Graph theory, is that what's called? It's totally new concept to me.
Yeah, graph theory, and it comes from actually super old school. I'm trying to think of what year it was. People were trying to understand how you can make like the least number of bridges in a town over a river, and try to figure out like what is the right routes and stuff like that. So this theory dates back hundreds of years, but we're using some of that on work today.
Very interesting. So Alex, what would you say is the most exciting part about doing, artificial intelligence and machine learning at SurePrep?
One of the things that I love about doing AI and ML here is just the scale at which we get to apply it on. We're being able to affect potentially millions and millions of documents, and not only understanding how they're prepared, but also how are they verified, and its value that we can see and measure. And so one of the things I really like about AI ML and when you're making predictions is, can you actually tell what value you're adding? And one of the great things about being at SurePrep is we can look and say, you know what, this document would have had to be 100% prepared by humans before, but now it's 95% prepared by our algorithms. Or if we didn't run this verification algorithm, we would have needed 10,000 human hours on this set of binders to go through and verify that every number came out of OCR correctly. But now we're seeing that we're cutting that number in half or in a third, or whatever aspect we're adding there. And so really just being able to see that scale and effectiveness and have it be very tangible is probably the number one most striking thing to me. Additionally, at SurePrep, I think what's really great about this space and about SurePrep as a company as a whole is that, even though I'm doing AI and ML, I'm actually under a larger umbrella of innovation. And really the focus of the innovation team is to take kind of ideas and try to run with them a little bit. We're not necessarily directly tied to a customer's question. And so we'll look at a field and say, you know what, I wonder if tax preparation could be done in a better way. Here's something that tax professionals have had problems with for years. Let's try something totally crazy. And what I love about that is we actually fail a lot along the way. And so for every success, you're probably not seeing 3 or 4 attempts that we're making that just don't work out as well. But being able to kind of have that innovation umbrella here really lets the team be creative. And when we do kind of hit it, when we do kind of hit the ball on one of these ideas, we hit it out of the park. A lot of times, we're doing these new things that are just totally kind of disruptive in this space, which is extremely exciting. Additionally, what's really cool about SurePrep is that I've worked in organizations before where the organization is just a piece in the ecosystem. And it's a very tiny piece. And so you're kind of creating some AI ML system and you're making some predictions, and those predictions go out in the world and you don't really know much about are they being successful? Are they doing the right thing? What I love about SurePrep is that we have a ton of experts in-house. And so when I'm working on verification technology, I can go talk to someone who's been thinking about this problem for 10 years in the field. And they can sit down with me, and while they might not know anything about AI ML, they can kind of point out the processes that they're doing as a person and say, oh, I always do this, or I always look here. And in the back of my mind, I'm thinking, oh, we could have a computer try to learn that. And then we develop with them, kind of looking over our shoulder, testing out our products, making sure we're actually solving problems in the right way. And then the last bit about being at SurePrep that's really interesting, and it kind of ties this whole experience together, is that we do get a lot of interaction with our customers. And so as I've been developing different products here, probably my favorite part of the job is to go kind of take a alpha product or a beta product, start demoing it to customers and getting immediate feedback as the product's still in works, to understand, hey, would this be helpful? Or would you want to see this in a different way? And we've gotten really good feedback from our customers along the way. Our customers have been really creative, and they've found areas that solutions that I've been building could be reused or could be repurposed that actually add a lot more value to their workflow. And so really, along with our kind of customer board, I really feel like it's a great kind of back and forth symbiotic work relationship where we're really working together to create some really cool things here. Yeah,
very neat. You mentioned documents or sets of documents that maybe in the past 100% of which needed to be prepared by people, and today maybe 95% of the work can be done by machines, which is obviously an incredible thing, especially since that kind of work, organizing work papers in a binder and doing data entry, that's not work that people want to do. It has to be done, but it doesn't have to be done by people. And so what this does is really elevate the roles of preparers and reviewers, because they no longer have to do this kind of work. So obviously the AI ML space is moving very, very quickly. So how do you stay on top of current trends?
Yeah, so really there's kind of a constant research that my team has to always be maintaining. And it's probably impossible to stay on top of every single trend unless you're entirely in the academic space. And so one thing we do is we try to hire people that come from the academic space who always keep us up to speed. We partner, I have a PhD student working with me right now who's in the AI ML space, and he brings a lot of new knowledge to us that's coming very directly from the field. The other area that we do to stay on top of current trends is as a team, and I think this is kind of unique to some of the teams I've worked on, but it's the culture that I'm really happy that we've been able to set up here at SurePrep. We actually have a research day every Friday where we will all go over a current hot topic in AI, whether it be a paper or a blog post or a new technique. We'll read through it. We'll try to understand it the best as possible. Not everybody on my team comes from a PhD AI background, AI ML, and so we'll go through it. We'll try to understand how does it relate to us, what areas can we understand, what areas can we help each other out on, and then we'll have kind of a brainstorming session of how could this apply to something we're doing at SurePrep, and we'll read some really kind of novel articles on areas where we thought, maybe this is some totally brand new part of AI ML that's, around how our language is translated. How do you go from like German to English and create like a translator that works 24/7? But then we'll start to see applications even in our own work, and we'll kind of brainstorm that. And a lot of times the result of this is, oh, that's cool. Maybe we'll do a little bit of research on applying this technique over to the work that we're doing here. And so staying on top of current trends, it's kind of a constant battle. You always have to be looking out for it. And I would say blog posts, conferences, everything. We try to do a little bit of it all, and constantly there's amazing work coming out almost 24/7, and so we bring that in as we can.
Nice. Follow-up question then, for listeners or viewers. So for the uninitiated, can you list a couple of podcasts or books that you'd recommend to people that want to learn more about AI and ML?
Yeah, I think one of the blog Medium has a kind of sub-blog called Towards Data Science, and that's a really great place where anyone on the internet, but it's curated through Medium, can write blog posts on current trends in AI ML, and that's something I get a digest of that every day. I'm looking at top articles. I learn a ton from that, and so that's one of the areas where I think is a great jumping off point to say, oh, here's a cool new idea, read a blog post about it, and then go read the paper if I'm super interested. Otherwise, I think there's, in terms of books and podcasts, et cetera, a lot of, I think the core of AI ML is really data science, learning how to kind of apply the scientific method to data. And so how do you run good experiments? How do you think about problems in the right way? There was a great book, I forget the author offhand, it's called Algorithms to Live By. And it's kind of almost I would equate it to like a Malcolm Gladwell style of how do you apply data science in your current life. So it'll ask questions such as, if you're trying to buy a new house, how many houses should you look at before you decide to put money down, right? Because you're like, maybe the best house is the fourth one, maybe it's the fifth one, maybe it's the 20th one. And that's just like these common algorithms on how do you work with data in your daily life. And a lot of it goes back to statistics, and it does it at a level where even if you never got A's in math class, et cetera, it does it at a level that's very accessible and really shows you that there's data science and algorithms in the world all around us. So that is a great text. I love that. Even kind of being heavier in the data science world, I found a lot of new insights from there. If you're in the programming world, there's a lot of people who are great engineers, but just have never explored data science and machine learning. The publisher O'Reilly has a book called Hands-On Machine Learning, and I actually have it in my bookcase behind me. It's this great book that kind of helps you transition from, I know how to work with computers really well, now how do I work with machine learning and AI, these kind of newer topics. And then in terms of podcasts, there's a lot of great podcasts out there around AI, ML. Basically, it's hard to pick just one. There's a lot of them kind of cover the topic from going into different models all the way to talking to experts in the field. And so really, even just like Googling, top podcasts for ML, you'll come up with a list, and almost every single one will be great. There's not enough time to listen to them all. One podcast, though, that I think is kind of an interesting one that people don't think of in the data science ML world, but has actually influenced my work a lot, is NPR has a podcast called Planet Money, and it's actually run by economists. And really, economists do a lot of similar work as data scientists. Economists are looking at different problems, and they're wondering, what are the incentives? What are the data behind a certain problem? And this is everything behind how do you control pollution in China to why is there a subprime mortgage crash, all of these sort of things. And why I say this relates to data science is they go through and they kind of ask the questions of what is the data that could be causing these problems? Can we create experiments to test these hypotheses? Can we, at a really scientific way, understand different things that are going on in our world? And really, I would think that that sort of data science, that sort of mentality is probably the hardest thing to learn when you're working in the AI ML space, because you'll make these models and the models won't turn out to be what you thought they were. And so you really have to take this scientific mindset and probe and say, all right, my experiment failed. Why is that? And you make hypotheses and you keep testing them again. So it's that scientific method that really gets driven in. And I think listening to that podcast has probably taught me more creativity about science than anything else.
Yeah, that's a good one. Planet Money is a great podcast. Speaking of blog posts, I actually wrote a blog post on a TED Talk that I watched probably 9 or 10 years ago called "Are Droids Taking Our Jobs?" I would recommend that one for anybody, for you or anybody listening. You go to TED.com and search for "Are Droids Taking Our Jobs?" Pretty interesting presentation. All right. I think this is the last question before we do the lightning round questions. So Alex, what advancements in AI or ML excite you the most? What do you see on the horizon?
Yeah. So there's a lot of really cool advancements that are happening right now. Some of them have to do with how do you learn with less data. And so one of the things that I think we've learned a lot recently with AI ML is that you often need a lot of data to do something. And so how can you learn? How can you teach a model to learn when data doesn't exist yet, for example? And so there's been this whole idea of reinforcement learning, and reinforcement learning kind of comes to the idea of if you have a model play a game, you're almost training a model similar to how you would train like a pet dog. Basically, you say like, oh, model, you did good when X, Y, or Z happens. Like if your score goes up, you did really good. But if your score goes down, like bad boy, like model, you didn't do well. And this has been really cool. It started actually being trained. One of the initial papers on reinforcement learning that was really influential in the field was teaching models how to play Atari games. And so now there's models that basically they'll start playing these games and they're horrible at it. But you train it by saying, oh, having a good score is really good. Or if you're playing Mario, not an Atari game, but Nintendo game, if you keep going to the right, that's good too. And these models will learn to be experts at these games. And so you can do the same sort of thing with different problems in any type of business space as well. If we maximize this sort of number, if we minimize the number of times it takes a human to do something, or if we make this more efficient, we can do well. And what's great about this is you're not collecting, you don't need years and years of data. You really can just let the model observe the world around you and make decisions. And so reinforcement learning, all under the umbrella of learning on less data, that's been really cool. There's been these type of networks called GANs, which again work on low amounts of data, but they're doing really cool things. So you're able to take a photo of a person and then kind of overlay it on something else and make someone like dancing, for example. It's just really cool tech that's coming out. And I think, the nice thing about this, and I think what maybe the world doesn't always see around a lot of this technology is that most of the artificial intelligence, machine learning world is open, meaning that all of the research is being published, even research coming from a lot of big organizations is being published in open academic journals, and it's all building on itself. And so really, we're just kind of having this tidal wave that keeps getting bigger and bigger of more and more people reading the research that's being done at all of these different organizations and improving upon it. And additionally, a lot of the AI ML models that people are using today are models that were trained on hundreds of thousands of computers just in these big computing farms, creating really, really powerful models. And then those models can be used by others. And so those models are even being shared. So a lot of collaboration in this space right now is really exciting. One other area kind of around AI ML that excites me is the explainability aspect. And so we were really content as a field treating models as black boxes for a while. We kind of understood how they worked, but we didn't really care as long as they gave the right answer. But now we're actually diving a lot more into explainability, and reasons why this is really important for us is not only more accuracy in what we do, but one of the biggest kind of concerns around AI ML is the ethics around it. And so by not being able to understand how something works, sometimes a model could create something that's extremely biased and could cause issues down the road that we might not think are ethical. And so this explainability research is really helping us tackle that and be aware of problems that models can have right off the bat. And then the last bit for me, AI ML that excites me is just computing technology is always getting better. They're creating specific hardware chips right now to do AI ML, faster graphics processors, et cetera. And so the amount of work that we can do and the speed at which we can do it is amazing. The kind of things that my team is doing at SurePrep probably would have only been possible to do on probably the biggest computing clusters at universities in the world, even 10 years ago. And so the fact that we can have so much power right now as a company and as individuals is really impressive for how far the hardware has come.
Yeah, I'm glad you brought that up, because I was going to mention it. You mentioned powerful models. I was going to ask about powerful computers, like, quantum computing seems like the kind of thing that is going to provide like an enormous leap forward. Is that something that you see, on the short-term horizon?
I think quantum computing is a little bit further out. I do think there are going to be some really cool aspects, especially in cryptography and keeping data secure, that I think quantum computing can bring. On the shorter term horizon, it's really kind of the way that people have used graphics cards, basically specific chips. So, graphics cards essentially do graphics for video games. And it turned out that all of those graphics for video games were matrix multiplications. It's just the same exact math that we're using in AI ML. And so the AI ML world kind of said, oh, we can do all of our processing on these cards. That's the sort of stuff that is really advancing the field right now. And with cloud computing, what's great is my team can buy a giant cluster of graphics cards, 20 or 30 of these things, where each card would cost probably tens of thousands of dollars. And we can borrow it for an hour, use it in the cloud. And then we can say, okay, cool, our model's trained, we're good to go. Now we don't need these anymore, and turn it off. And so we're able to kind of rent these super powered computer clusters for terms of hours, and then not have to use them again. And so it's awesome to be able to share that time using cloud tech.
That's incredible. Yeah, wow. Okay, Alex, enough of the serious questions. Are you ready for the silly question lightning round?
Let's do it.
Okay. First lightning round question. Who wins in a fight? Vicky, the robot from the 1980s sci-fi sitcom Small Wonder, or C-3PO?
Oh, man. Small Wonder might actually be a little before my time. I think maybe I'm dating myself a bit there. Oh no, actually, a quick Google search. I totally remember Vicky from Small Wonder. So I'm actually gonna put my money on Vicky here. I think there's a little bit more human elements, a little bit more creativity here, and I think C-3PO is gonna freak out a little bit more, while Vicky is probably gonna keep it calm and collective and kind of get the job done in a fight here.
Totally agree. C-3PO is a little unstable too. I think Vicky takes C-3PO easily.
Yeah.
Sorry, Star Wars nerds.
Yeah.
All right. Second question. The movie Ex Machina, good movie or great movie?
Ex Machina is great. Yeah, I've actually watched it multiple times, both as a kind of AI ML nerd, but then also just as like visual movie buff, both in my book.
Agreed. Great movie. Next question. Will our future robot overlords allow us to take breaks?
I think like probably when we're mining lithium for them or whatever it is, they'll probably efficiently allow us to take breaks as much as it increases our productivity. So they'll have it modeled out the exact amount of time that we need breaks in order to do our work as efficient as possible for them.
Interesting. I was going to disagree with you, but I actually, hearing your answer now, I think you might be right. As long as they are able to maximize efficiency, I think they do give us breaks.
Mm-hmm.
All right, next question: red pill or blue pill?
Ooh, I always see that. Yeah, are you being red pilled or whatever? I think let me think about this. This is throwing my sci-fi thing into it, right? The red pill is like when your perception is totally dramatically transformed. And so when I think of disruptive technology, I think I have to go red pill on it.
Yeah, I think you're right. I think red pill is like the willingness to learn the truth, however painful that may or may not be. So I agree. I think red pill.
Yeah.
Two more questions. Does Santa Claus use artificial intelligence to help deliver gifts on Christmas Eve? Because the productivity does not seem achievable without it.
Yeah, there is the traveling salesman algorithm is a classic algorithm, and it's how does a salesman get to every point in the United States in the shortest amount of time. And so I believe that somehow Santa Claus must have the most efficient algorithm solution to that in the world of how does he get to every single point in the entire known world in the shortest amount of time. So in order to do that in one Christmas Eve, I think for sure Santa's using AI ML.
Agreed. Has to. The efficiency can't be explained in any other way.
Yeah.
Okay, last question. Can a Roomba pass a Turing test?
Ooh, yeah, let's see. Yeah, so I think a Roomba, potentially, we could get it to probably pass a Turing test. I'm thinking I do have my own Roomba, and I think I have mistaken it for, I've come home and I've looked at my wife, I've been like, oh, you swept. And she's like, no, the Roomba did it. And so at a very level, that Roomba has tricked me into thinking that it was a human for a little bit. So I'm going to say, yeah, sure. I think we're getting close there.
There you go. I agree too. Alex, awesome conversation. Thank you. I think this is going to be really interesting for SurePrep customers or maybe future customers that just want to learn more about AI in general and SurePrep's initiatives in the space. So thanks for joining me.
Yeah, thanks. It was a lot of fun.